Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to resolve base classes. So in this video, we're basically going to be talking about how to compile and resolve classes when it comes to building like a class hierarchy, right? So if I go to my syntax file that we always use, where is that at right here? And as you know, every file or every class, so if I have like this house, it may have a base class of building, right? So we may have a base class of building, and then we can create a class of building here, ILDING, and building could have other stuff inside of there. So we want to basically figure out like a basic hierarchy of every single class. So let's see how we do that. So again, we're still in the pre-process method, so this is just going to go right below the handle imports function that we went over in the last video. So for this one, what you want to do is, again, you want to go through all of your parsers or every single file, and you want to do like the basic stuff. So you guys know what this is. It's the same in every single function call. You want to for loop through your parsers, set the current parser, update the error management system, grab the current total count of errors that we have, and create a new scope of a global scope that's going to be set as a result of our first module that we're going to process as the first AST. Same stuff we always do, so don't really have to go over this portion of it. But if we scroll down, we can see, of course, we're going to need to have a switch statement on our branches after we've figured out pretty much what our module is and everything. When we process this information, we'll be all good to go. We, of course, want to, as usual, check for any compiler errors, like if we went over the maximum error limit. After that, you want to, as usual, check to see if any new errors were found. And finally, of course, you want to remove the scope because we added it up here previously. So now what we're going to do is basically when it comes to resolving like a basic class hierarchy structure of every single class, understanding what the stack of all the classes are, it's going to be relatively simple. We're not going to be doing too much work. So all we want to do is we're going to start off by, of course, ignoring anything other than the stuff that we're caring about. But we're going to basically focus on three main parts. We're going to focus on classes, interfaces, and enums. Now, enums do not have a superclass by default because that's actually not in the syntax. So if we go up here and we create a enum of color, we can't have a base of some other enum. That doesn't, my compiler doesn't allow that. We'll see how that works shortly, but you definitely want to do that for enums. So I think it's actually in the compiler 2 file. Yeah, okay. So you want to create this resolve superclass function. Now, what this function does is, as you can see, we require not only an AST, but a current class as well. Now, if we go back, if you notice, at the highest level that we're at in resolve base class, we are not passing in the current class because we're coming in fresh. This current class is going to be set null by default. So if we go to our compiler header file, you can see current class is set to null by default. We do this because we want to make sure that when we're processing any generic classes, if we want to resolve the superclass of that generic class, all we have to do is just pass in that as the current class we are processing, and everything will just work magically. So we'll see how that code works a little bit later, but if you notice, my compiler is all about code reuse. And I'm going to say it now, and I'm going to keep stressing this to you guys. You want to reuse as much code in your compiler as possible because you don't want the compiler to get too large. I ended up doing a lot of code in my compiler when I was doing things yesterday, and my RAM usage got up to close to 10 gigs. So if you increase the amount of code that you're reusing, you keep down the amount of code that the compiler and the IDE has to process, and it's just easier to manage. So for our resolve superclass, we're going to need a couple different things. We're going to need the block. That's going to be the block that is inside of the thing that we're processing. So if you remember, we're processing enums, classes, and interfaces. All of those are going to have blocks, so we can just access that data that way. We also want to get the branch, or we want to create just a local variable here for branch. Now here's where we do our preliminary stuff. So when we come in here, we want to check to see if the current class is equal to null. And for our case, in the example that we're going over now, I'm going to just show you guys how classes work. Then we'll talk about enums a little later. In our case, current class will be equal to null, at least at the current state of where we are in our compiler. You want to get your name as the first token. That's going to be what we're going to access. And then you want to check to see if the current AST type is equal to a generic class declaration or a generic interface declaration. The reason why you want to do that is because if you remember, whenever we're accessing classes, we always put this as a as a postfix to the actual name. So when we go down here to resolve it, we can actually access and get the appropriate class that we need to get. So what we're going to do is we're going to check to see if we're at global scope, and we're going to say current class is equal to find class. Now, what we're going to do is we're going to pass in the current module, the name, and then we're going to check to see if the AST is equal to a generic class declaration or a generic interface declaration. If so, then we want to get the generics, or we want to use the generics class list, because as you know, we access or we put the generic classes in the generics class list because they haven't been created yet. Otherwise, if it's a normal class, in our case, we want to put it in the classes list. So we're going to access that information that way. And we've already gone over find class, I believe. Yeah, we've already gone over this code, so I don't really have to go over that. So after that, otherwise, if it's not at a global scope, then you're just going to get a child class as normal, and that's pretty straightforward. So we're going to do a check to see if the current class is not equal to null. This is important because it's entirely possible that the current class is equal to null, even after all of this information here. So it's just a safety precaution to check. I actually think that this was related to a previous bug I had. Pretty sure it's fixed, but it doesn't hurt to just be safe. So the first thing we want to do is we want to add a scope. We want to add a class scope of the current class that we're processing. Makes total sense. And we want to do what's called resolving the base class. Now, let me see. Yeah, we should probably go into that function first. Okay. So this is a little bit of a rabbit hole, but hopefully this video won't be too long. This one's gonna be a little bit longer. I've been keeping my videos around 20 minutes before. All right, so if we go into resolve base class, we can see that so first thing we wanna do is we wanna pass in the current AST. So that's gonna be the AST that we passed in from the resolve superclass. And we wanna check to see if the AST has a sub AST of AST reference pointer. If I go to my parser, and the front end part of our compiler, and I search for, what is it, parse class declaration, and then when we go in here, so you can see that we have our identifier as the class name, which is the first token that you guys saw we accessed in the function, and then we skip over this code because it doesn't matter for the case of what we're going through now. But as you can see here, we have a base, the base keyword, and it's referenced as a reference pointer. So what we're going to do is we want to check to see if the user has a reference pointer as the AST, and we're just going to return base. So we're going to set base to null. Now, if it does not have a base class, then it won't have this AST. So it's perfectly fine to just return base as its default value. But if it looks like we do, then we want to create what's called a reference pointer. You guys remember, reference pointer is basically a way for us to access data in a hierarchical manner. So if I go back, so what we do is we call a function called compile reference pointer. Now what you're going to want to do is pass a reference to the reference pointer that you want to inject the information into, and then you also want to pass in the AST of that reference pointer that you want to process. So let's actually go into that. Now I think this one, yeah, this video might be a little bit longer. Okay, so in order to compile a reference pointer, what we want to do is check to see if we have a hash that's been found. Now, this video could probably end up being like 3 hours long. Don't want it to be that long, but we're probably going to skip over a little bit of code here, so just keep that in mind. But you want to say whether or not we have found a hash, and we want to have another one that says hash processed. We want to create a module, local variable, a generic list, position, local variable, a parent, and failed. Now, here's where it gets a bit weird. The way that this kind of works is as we're processing the ASTs, we're going to be processing various amounts of tokens. Now, the way it's going to work is, let's say we have like a token here, and I'm just gonna copy this. So let's say we have, for example, I don't know, list of var dot, and then let's say the list class had a subclass of foo dot some generic, so or some gen. So let's say we had some generic class of I, or of maybe not I, maybe of like int or something, some other type. The way it's going to work is we're going to have the list, foo, and some gen token. So we're going to have all three of these. So do I still have it copied? Yeah. So we're going to have list, foo, and then some gen. And that's going to be the flow of the actual tokens. Now, in terms of the ASTs, in this same AST that we passed in here, we're going to also have a list of, what is it called? Reference identifier lists, I'm pretty sure. So if we go back to the parser, we go to parse reference pointer. So yeah, so oh, it's a U-type list. Okay, so we're going to have an array of U-type lists. So we're going to have also in this AST a U-type list, and we're going to have two U-type lists. Hopefully you guys are following along and this isn't too confusing. But as we're processing this, we're going to need to keep track of our generic list position. What that's going to do is every time we encounter a less than symbol, we're going to basically access a U-type list at the current generic list position. That's kind of how this works. Now, we're not going to go into how to compile generic class references right now, because this is a huge rabbit hole and I actually don't need to do anymore. And it's going to require a lot of more code to be there, and we're just not at a place to do that yet. So we're most likely going to skip over that code, but I want to explain this to you guys early on so it makes sense. So that's kind of how it works and how this code processes everything. So hopefully that's a little bit more clear, but let's just quickly go through it. So we want to for loop through the entire AST, and we want to for loop it based on the tokens that we process. So if we haven't found the hash and the hash hasn't been processed, we want to add the data to the module here. So, and of course, we're still going to also have the dots as well, I think. So we'd have list and then a dot in between each of these tokens here as well. So we're going to generate the module by just adding the data to the string stream. And then if we've encountered it, or actually if the next token is a hash, so we don't even wait for it. We just check to see if the next token is equal to a hash. Then we say we've processed the hash. We set the pointer dot mod, which is going to reference that's going to represent the module that the data that we're processing in this reference pointer is residing as. So we want to set that value, and then we want to plus plus I. That way we can skip over this token here. So once we have our module, and again, the user doesn't have to have a module, but in that case, what we'll do is we'll say string name. And of course, this code, by the way, is not going to execute if we do not have a hash. So we're gonna do the check. That's why we do the check initially, where we check to see if the AST has a hash. If it does, then we will generate this module. Otherwise, we'll just completely ignore this code. So just keep that in mind. So we get the name based on the current token at a current index of I, and we check to see if the name is not equal to a dot. Now, if the name or the token is not equal to a dot, then we process the information in here. Otherwise, if it's a dot, we just don't care. So we completely ignore it, and here's how this kind of works. So ignoring this code for now, what we do is we say pointer.classes, and we add the name or the current token that we're processing to what we're actually processing. So let's say let's do a different example. Let's say we just had a regular list class that wasn't a generic. When we say list.foo, what we're going to do is we're going to add the list as a name, and then we're also going to add the foo as a name as well. And as we're adding those names, we're going to have a Boolean that says whether or not we failed. The reason why you want to do this is because as we are compiling our code and we're nesting or we're going through the hierarchy of accessing information, we want to keep track of what's the current class that we're processing. So as long as we haven't failed, we want to check to see if the parent is equal to null. If so, then we want to set the parent, and the parent is going to represent whatever the last thing that we're processing is going to be. And we want to basically call resolve class, and we want to resolve this class by getting the module based on whatever the pointer.module is. And if the module is empty, it'll just return null, and that's totally fine. We pass the name and the AST. Now, when we resolve a class, what we want to do is, I actually don't think we've gone over this function before. So I'm actually going to just quickly go over it. I apologize if I've gone over this before, but I can't remember unless I write comments literally on every single function. So what we're going to do is we're going to need to pass in the module. We're going to need to pass in the name and the AST that it's just used for error purposes, error reporting purposes. It's not used for anything else. So we're going to set the class that we're going to be processing to null as a default value. We're going to check to see if the module is not equal to null. If the module is not equal to null, that means that the class that we're resolving or attempting to resolve absolutely has to be inside of this module. Otherwise, we're just going to return null. So we're going to say class.find class, the module that the user is explicitly trying to find it at, the name, and then the classes list. And yeah, we've already gone over the find class function. After that, we want to do what's called validate access. Now, I have a couple of these functions, but what this does is this ensures that we have access privileges to this file. So we're going to need to pass in the class and the AST. So what we do is we basically say we want to pass in the class object in the AST, and we want to check various different levels of access. So we're going to have at the first level, we're going to check for local. And local access specifically declares, based on our rules, that you can only access a thing if it's defined, if you're inside of the class that the thing was defined in. So we're going to get the current scope, and we're going to say we're going to get the file from the current parser. So we're going to get the current parser, get the tokenizer it's referencing in the file, and then we're going to get the file from the code obfuscation system. We're going to check to see if that reference to that file is equal to the file that is located inside of the metadata of the thing that we're trying to access. So this is a reference pointer here. So we just check to see if those pointers are equal. If they are, great, then they're both in the exact same class or the exact same file. And if so, this is just an empty if statement. Ideally, you just say if it's not equal to file, then error out, but whatever, it's fine. But if it's not equal to it, then I'll say invalid access to localized class of whatever. Now, here's something very important. Please put the full name of the class, because the user's not going to know exactly what you're talking about if you just say class of A, right? And if he has 5 different classes of A, and you're not putting the full name, he's not going to know what module it was defined in, what was the class hierarchy that it was defined in. So just make sure you put full name. After that, you have private. Private is basically going to be private, right? So you can only access a private value if the class is related to the class that it's in. So what we're going to do is we're going to say scope class is class related, and I actually believe we've gone over this function before. So if you guys want to learn about this function and how it works, you can check out my previous videos that I did about setting up the compiler initially. I think it's on like part 1. No, it's on part 2. I'm pretty sure it's on part 2, so you can check that out. But if the class is related, then we're fine. Otherwise, if the class isn't related, we say invalid access to private class of whatever. After that, we have protected. Now, protected has better access privileges. Protected basically allows you to access the thing that you're trying to access inside of, like, if the classes are related to each other, meaning that we're inheriting the class, or if we are in the same module, right? So if we're in both the module of STD, we can also access that class as long as we're in the same module. So we do that. Otherwise, if that's not true, then we want to say invalid access to protected class of whatever. Otherwise, access granted. So that's what validate access does. I have a couple more of these functions, so we'll just go over them as time goes along. I have it for functions, fields, and other stuff as well. So after that, we're going to validate the access. Now, whether or not the access was valid, we don't really care. Pretty much the compiler is going to either report the error and we move on, or it's not. So we don't really care. We were able to successfully resolve the class, so we want to still be able to return that reference because technically the class does exist. So yeah, after that, otherwise, if we can't find it, then we just return null, of course. Now here's going to be the first example of where we actually resolve information in my programming language. So this is kind of how I resolve classes and figure things out based on the imports that you've passed that we saw in the previous video. So the way we resolve classes is you want to for loop through the entire import map, and you want to check to see if the name of the key is the same name of the file that we're processing, right? So the name of the key is going to be the file data. It's going to be the name of the file, because if you remember, the key is reference to the file data. So we want to pass that in, and if that's the case, then we want to basically for loop through the entire list of module data. So we want to basically have our list here of a reference of module data, for loop through there, and just find the class for each module. So we want to basically try to find the class at module A, B, C, and D of any of the things that we've imported, and if we can resolve that, then we validate the access and we return class. And this again calls that same function that we've gone over previously. So that's pretty much it for that, and otherwise we just return class. Most likely by the time it gets down to here, it's going to be null. So there's that. So yeah, so let's go back. All right, so once we've kind of resolved our class, so that's like a basic way of how we resolve classes in the language. We're going to set the parent class to that, and after that we're going to set the parent class equal to the child class if the parent class is not equal to null. So the idea is that it's going to be a child class inside of there, and we're going to set failed equal to parent is equal to null, right? Because obviously if the parent does not have a child class of whatever and it's null, then we don't want to continuously try to resolve um, any subsequent classes after that, because obviously that's going to cause a compiler error. And the reason why we want to do all of this is because once we generate or once we compile our generic class, we need to pass in the parent class that the generic class is going to reside inside of, so that we can compile that generic class properly. So that's the main reason why we want to keep track of what the parent class is. So if we go up to the top here where we're actually doing the processing of generic classes, this goes back to that example I showed originally. If we haven't failed, and of course failed is going to be represented down here, what we're going to do is we're going to say if I plus 1 is less than the token count, and the ast.get token at I plus 1 is equal to less than, and that's why we want to do that, because we want to basically do a check. So for the example of list of var, what we're going to do is we're going to have, this is how it's going to basically look. We're going to say list of less than symbol, and then we're going to have the dot. Now obviously this looks a bit weird, but basically the way we resolve generic classes looks exactly like this. So this is going to be basically the format that we're going to be seeing as we're processing our information. Once we have a less than symbol, we basically extract one of the utype lists based on whatever the generic list position is. So what we want to do is we want to have, so this is going to be our first define statement. It's going to be called retain type instance, and we're going to set this to false. The reason why we want to do this is type inference is basically a way to trick the compiler into forcing whether or not we can process a type. So in short, I'll just give a quick example. The way this works is, let's say we have like this variable here, right? Count, right? Count is equal to 0. It makes perfect sense. You obviously know this is a number. You don't want the user to be able to say var. So the way it works is, as we're processing types, if we put the compiler into type inference mode, we can't have what's called a hard type, meaning that it can't be like var, or like, I don't know, it can't be, count is equal to string, because string is technically a class, meaning that it's not an actual value. It doesn't evaluate to anything. It's a hard type. So that's going to cause an error. If type inference is false, then we will allow both hard and soft types. Soft types in my programming language basically represent values that evaluate to things. So like numbers, strings, and so on and so forth. So there's that. So we do that. All right. So where were we? We were in the compiler 2. So what retain type inference does is it basically creates a old type inference boolean and stores the current value of type inference. And then we want to set the new value of type inference based on the data that we passed in here, which as you can see is false. The reason why we want to do an old value is because we want to restore it to the previous value, so that way we can constantly keep modifying the state of type inference without really having to care about what the old value was. So we want to create a generic class object, and we want to just create this function right now. Don't do anything yet. Like I said, we will revisit this function much later in the compilation process. But what you want to do is you want to create a compile generic class reference. You want to pass in a module. You want to pass in the name. You want to pass in the parent class that this generic class is going to reside in, and the AST. And once you do that, we'll go over what that function does later. So what we're going to need to pass in is we're going to need to pass in the current module of the reference pointer, the name of the class, the parent class that the generic class is going to reside in, and we want to say get sub AST at generic list position plus plus. And as you can see, this is how this kind of works where we access these sub ASTs. These are tokens, so you don't have to worry about accessing the AST at an incorrect position because tokens and sub ASTs run on two different lists. So you don't have to worry about that. And then of course, we want to set the pointer.classes. We want to add the value of generic class. So we want to check to see if generic class is not equal to null. And this is just a simple way of doing it. If generic class, we want to pass it the name of the generic class. Otherwise, we want to pass it a question mark. The question mark is going to eventually generate an error later on in our compiler because you can't physically create anything that has the question mark symbol in the name. So it's going to just generate an error later on. After that, you want to set the parent to whatever the generic class is. Makes total sense. And you want to set failed whether or not the parent is equal to null. And then we want to plus get I of 2. So currently we're at list and we're here. So we want to do I plus 1 and then I plus 2 because we also want to jump over the dot as well. So that when I plus plus is at the end of the for loop, we are at the foo portion. And then finally, we want to restore our type inference. So once we do all of that, so if I go back to my compile, preprocess, where are we? We're in the base class and then resolve superclass. Once we've done all of that, and we were in resolve base class. So once we have successfully compiled our reference pointer, we basically need to resolve a class reference. And we want to say base is equal to resolve class reference by passing in the current AST and the reference to the reference pointer. Now, I don't want this video to drag too long, so what I'm actually going to do is I'm actually going to split this video up into several different parts. So we're going to continue this next week on Monday where we talk about how to resolve a class reference because this is actually a pretty huge function and otherwise this video would be like an hour long or something. So we'll do that and then we'll finish up on resolving a base class. And once we're done with all this, we're going to start gearing up to start writing the virtual machine. But hope you guys enjoyed the video. As usual, if you have any questions, definitely put them in the comment section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you do, definitely watch, start, and fork this repository. That's going to give this repository a lot more visibility and let other developers know this language exists. Also, if you guys are curious about what I do on a daily basis, you can head over to the remastered branch. In there, I do pretty much daily updates on the actual language, and I write some pretty decent commits, so you can kind of get a gist of what I've been up to without really having to look too much in the code. Also, if you guys are curious about learning some of the things that I'm looking to add in the future or stuff that I've done in the past, you can head over to the docs folder. There's two main files. There's a change list file that pretty much contains everything that I've done in the past to the language. And then there's the roadmap file, which contains not only that, but also stuff that I'm looking to add in the future. Now, as a final note, before I go, I want to show you guys something that happened today. I actually just released version 0.2.805 of the Sharp programming language. The last release I did was of September of last year, so I just did this like 36 minutes ago. So if you guys want to check out the language, give me feedback on the language, you can do that. You can play around. I don't really have any documentation yet because the language is still built. I'm still building on it, so it doesn't make sense to spend all that time to do that, and the language keeps changing. So would love to hear you guys' feedback. There's a couple different files in there that kind of tells you how to get started with the language and to get things set up. If you guys have a Linux machine, it's a lot easier to install it on a Linux machine. You literally just run the Linux install bash. Otherwise, if you have to run it on a Windows machine, it's going to take a little bit more work, a little bit more manual work for you to do that. But yeah, I definitely recommend checking out that version. And as you can see, I finally pushed to the master branch. So all of the code that I've been working on up until this point is now in the master branch. So hope you guys enjoyed the video. As usual, if you're new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.